Problem number 3. Josh and Mike live 13 miles apart. Yesterday, Josh started to ride his bike toward Mike's house, and a little later, Mike started to ride his bike toward Josh's house. And when they met, Josh had ridden for twice the length of time as Mike and at 4/5 of Mike's rate. How many miles had Mike ridden when they met? Alright, we need to break this down so we can figure out what to do with all this information, okay? Um, Let me draw a little picture. I'm going to draw a little house here. And we'll assume that they're on a straight line here. Their houses are, um, you know, they're a certain distance apart. They're 13 miles apart, right? So the distance here is 13 miles from Josh's house to Mike's house. We'll call this Josh's house. I'm going to just put J here for Josh, and Mike, I'll put an M. Alright, the total distance is 13 miles. And they meet somewhere along this path. So, they say that Josh starts first, and then Mike starts later. We don't know how much later, but they meet somewhere. So I'm just going to pick a point on here, and I'm going to say that they meet, I don't know, let's see, right there. Alright, and when they meet, Josh has traveled some distance. Alright, so I'm going to call this DJ, D sub j, for Josh's distance, and I'm going to call this distance D sub m for Mike's distance. Okay, and so here's Josh's distance, goes from his house to where they meet, and Mike's distance is here. Okay, and we know, because they met somewhere, that the total distance, I'm going to say dj plus dm is equal to 13 miles, right? Because they had to cover the whole 13 miles between the two of them. Otherwise, they wouldn't meet, right? So we can say that this is a d. We can say that the sum of their distances has to be 13 miles, okay? All right. Okay, so that's part of the information that we have, but that they live 13 miles apart, right? And they both start riding, and they meet each other at some point. So from that, we can get that Josh's distance plus Mike's distance is 13 miles. All right, what other information are we given? We are given that when they meet, Josh has ridden for twice the length of time and at 4 times Mike's rate. Okay. Alright, so we know something about the time. I'm going to define some more variables. Okay, I've already defined 2. D is Josh's distance, or DJ, sorry, D, oops, so J is the distance that Josh rides. So I'm just going to call that Josh's distance. Alright, and dm is Mike's distance. And then we know something about Josh's time and Josh's rate with respect to Mike's time and Mike's rate. So let's define some more variables here. Let me give us a little more room. Let's define a couple more. Okay, we're given something about Mike's time. So let's, Mike and Josh's time. So TJ, we'll call that the amount of time that Josh rides. So this is Josh's time. Alright. Time. And TM we'll call Mike's time. And we know that there's a relationship between the two. They say that Josh has ridden for twice the amount of time that Mike has. Okay, So I'm going to write that down over here. I'm going to say that Josh's time is equal to 2 times Mike's time. Okay? I'm just turning this statement, this part of the statement here, into an equation. Okay? That's just that part transformed into an equation. Okay? Josh's time is twice Mike's time. Okay? Alright, and then we're also given that Josh's rate is 4/5 of Mike's rate. So let's define a couple more variables. Rate, I'll just say R. J is Josh's rate. Okay, and RM is Mike's rate. Rate. Okay. And we know something about it. We know that Josh's rate, so RJ is equal to 4/5 of Mike's rate, so RM. Okay. And we also know that if we take the rate and multiply it times the time, we should get the distance, right? Assuming the rate's constant, then rate would be something like miles per hour, and multiply that by hours and we'll get miles, right? So we know there's a formula: distance equals rate times time. Okay? And I'm actually going to sub two equations because we have two different distances. We have Josh's distance and Mike's distance. So I'm going to call this one DJ. So Josh's distance is equal to Josh's rate times Josh's time. Okay? And we can also say that Mike's distance is equal to Mike's rate times Mike's time. Alright? Alright, well, we got a lot of information here. We've converted, I think, pretty much everything that was up here in the problem statement to equations. You know, we have the relationship between Josh's time and Mike's time, Josh's rate and Mike's rate. We know the total distance is 13 miles that they have to cover. So let's just take what we have and plug it in and see what we get. Okay, we can do some substitution. Okay, so let me say, okay, we know we've got a relationship up here with Josh's distance and Mike's distance, right? So Josh's distance plus Mike's distance. Now we know that's 13, but we also know that it's RJ TJ plus RM TM. Okay, that's just substituting RJ TJ for DJ and substituting RM TM for DM. Okay, so this is the same thing. Okay, and then we also have the relationship between Josh's time and Mike's time. So we can take anywhere we see Josh's time and we can substitute this. Okay, so we're going to bring that down and get rid of TJ and replace it with 2 times Mike's time. Okay, and wherever we see RJ, we can replace it with 4/5 of Mike's rate. Okay, so we can take that and substitute it in there. Okay, let's see what we get now. So we have 4/5 of Mike's rate times, I'm going to put parentheses here, 2 times Mike's time, right? That's just the substituting for RJ and TJ, right? Using these equations here. And then I'm just going to leave this part alone, right? And that reduces the number of variables that we had. We had 4 variables here. We had TJ, RJ, and TMRM. Now we just have everything in terms of Mike's rate and Mike's time. Okay? So TM. Okay? And we have to remember that what we've been doing all along is substituting into our original equation, which was DJ plus DM, and that is equal to 13, right? We'll just bring that down There. Okay. Okay. Well, multiplication is commutative, so I have a couple of constants here that I think I like to combine. So 4/5 times 2 is just 8/5. And that's RMTM plus RMTM, but we could write that actually as 5/5 RMTM. All right, and that just, you know, I like to, you know, this is like 1 times that. All right, this is just another way to write 1, but it's convenient because we have something in terms of fifths over here. So if we write our 1 in terms of fifths, then it's easy to combine these two, right? Because we have this RMTM, okay, and that's equal to 13. All right, so let me just give us some more room. All right, so 8/5 plus 5/5 is 13/5, right? So we have 13/5, and RMTM is just DM, right? So that's Mike's distance. So I probably didn't even need to write that out as, yeah, I can just use DM instead of RMTM, okay? Because I guess I have it here, right? So I'm just substituting back. I substituted here, but I didn't really do anything with it. Now I'm substituting again. So, all right. Now we've got 13/5 d times Mike's distance is equal to 13. Well, if I divide both sides, well, I'll just multiply both sides by 5/13. Okay, the reciprocal. And that makes 13 over 13 is just 1, 5 over 5 is just 1, but I have to do the same thing to both sides, so let's multiply this by 5/13. Okay, 13 over 13 is 1, so Mike's distance is 5 miles. Aha! Lovely. There's the answer. We'll see you at the next problem.